Well, hello. This time I'm going to show you the latest update on my CNC router. To begin with, I decided I wanted my CNC router to have home switches just like my 3D printer has limit switches because it's very convenient. You just instruct the controller to go home and all the access is moved to home, and then you have one less thing to worry about. So to begin with, I just designed my limit switches using first Autocad. Um, so this is the X and Y design. That I created. Basically, it has two 2mm holes here and here. That's where the limit switch mounts to. They're about 9.5mm apart, and another mounting hole here for the screw that it will be mounted on to the body of the router. And I added some stress relieving fillet kind of radius, and this is the product once it was printed. This is the first two ones that I built here. The holes were a little bit too small. They were actually 1mm in diameter, and the plastic cracked. But you can tell that it's very strong because of the design, and it's about 5mm thick, and this radius here makes it very strong and it will not crack. So actually cracked because the screw I was using was too big for the tiny holes, so I increased the hole mean diameter. And also designed one for the Z-axis. Let me open that one. Close this. Nope. Let me open. This is the first design that I built for the Z-axis because it's a different way it is mounted. You can see it right there. And this is the first design that I built, was to be mounted upside down like this. So it was going to be mounted, actually it was mounted like this, but by doing that the axis will move downward and it will dangerously touch the table, and if I have a part it will just lean against it. So the natural way is to have the axis reference going up in the positive direction. So this is the first design. It's nothing wrong with it, just I had to redesign it. But you can see it's a little offset. It's the same concept as these, but it's larger, and of course it's offset. So I redesigned that, new measurements, and that's just the newer design. And that's the one I just mounted. Same, everything has a stress reliever radius here, and a mounting hole, and the limit switches holes right here. So that's the design. And moving onward, this is a simple shape using some fillets and lines that I've converted to a G-code. So first thing is you gotta save this as a DXF. You gotta save this as DXF. So you save your file as a DXF format, draw and exchange format. And once you get the file, you open the ACE converter. You take a file, DXF format. Take your file, like I don't know, test or something, and then convert it, and then you have the output, which looks like this. Something looks like this, sort of. Let me open it. Yeah. So, and then you add a few some starting commands like this header here, G71 for units in millimeters, G90 for absolute, G94 for feet per minute. Then you set your feed, and then you add start spindle and all that. Your start spindle, I think it was added once I transfer it to that laptop right there. So from a drawing in AutoCAD, you get a DXF file, and then you convert it to G-code, which is okay. So this is a program I was showing you right there. Just add these lines, this header here, start spindle, right? I added it here, and 3.5 is defined on the ACE converter. You just define the height at which is going to, Z offset and Z pass and all that, and you define this for layers. So you have different layers. You can print one, then another one, and then so on, and then create your, so you can have like different layers and then create a 3D drawing out of that. So this is it. I'm ready to execute the program. Single cycle here, and once I press start, I'm gonna light this. Let me put this lamp on my head because lighting is not so good here, and honestly my cell phone is a Huawei or whatever it's pronounced, and the camera just sucks. The optics are very bad. I'm gonna start here. So this is going to make the same pattern that I showed you here in AutoCAD. This is going to come out here. I actually painted the plastic, but the plastic is like this, clear, and it's hard to see. Actually, the second time I printed a pattern, I don't know if you guys can see it, but it's already here. But of course, if I wanted to be shown in the video, I had to paint the plastic with a red coating of spray paint, so you will be able to see it. Now, first, apparently the ACE converter first prints the solid straight line, and then it goes and cuts the arc in the counterclockwise direction. Let them see. Meanwhile, the program and Prusa CNC is running, showing you which line it's being executed, telling you what the current position is, which axis is in motion, and all that. So I still have a lot to learn about feed rates and all that. I haven't actually done any calculations to derive the feed rate. I'm not sure what the RPMs on my spindle are. I have to find that out. There you are. And then it took 3 minutes and 44.36 seconds to terminate. And let me just loosen the clamps here. So this is the outcome of the milling process. It's supposed to be facing this way, and that's right there behind me. I'm trying to overimpose the images. Of course, I suck at video editing, but that's the whole idea. I mean, it's to take a drawing from AutoCAD and create your own design. So this could be like a D or something, or, you know, whatever you want to do with it. Of course, I still have lots of work to do, like calculate what the proper RPM and feet per minute should be. I could probably add a pulse width modulator to control the RPM. I mean a triac controller to the spindle and control its RPMs with a knob. Measure what should the RPM, I mean the fit per minute should be for this plastic material. You know, I had to find out what the proper, and I'm just using a drill bit that I sharpened with another Dremel to have like kind of a cutter. So I'm actually not using any carbide or anything. It's just simple household items. So that's the fun thing about doing it yourself, you know, and learning in the process, because the main goal of this is to learn how to program CNC, how to use subroutines, motion commands, and all that, interpolations. So I have this CNC router for 12 years. I've been doing little upgrades like replacing the Z-axis feed, the mounting. Now the latest addition is the home switches, but so far so good. Now that I've discovered 3D printing and AutoCAD, I'm doing a lot of work with AutoCAD, you know, both with the 3D printer and the router. So if I have like a special part to mill out that I want to use, and probably out of metal something, I have to find out if I can mill aluminum or brass with it, so I can make metallic parts with my rotor. It's a possibility, but it's the fun thing about experimenting. So thumbs up if you liked the video, and I'd like to thank you all for watching.